Okay, so one of the most difficult things in programming is to get a handle on what's happening in memory. And there's this thing is called scope. Scope refers to when and where you have access to what variables and what data in memory and what each variable is really pointing at. So I've got this diagram that hopefully kind of conceptually lays out what's going on in memory. This is the little bit of that cloud that I often refer to as a heap. All objects live in the heap. So say we have an object that is a board. That object has certain variables inside of it. One of those variables is my squares. My squares is an array, a two-dimensional array of squares. And so I've kind of drawn that out. That's all of the squares, and it's got 9 columns and 9 rows. And I've written up here the indices. Notice that whenever we have an array, the very first element is always at index 0. So the first column is column 0. The last column is column 8 if we have 9 columns. If we have 9 rows, the first row is index 0 and the last row is index 8. And the variable my squares holds the address where that two-dimensional array is stored. Now it's a two-dimensional array of squares. So in that two-dimensional array, it is holding the addresses of a bunch of squares. Each square is an object. And so inside of this element of that two-dimensional array is the address of a square. And a square has its own variables. One of the variables for a square is possibilities. And each of those variables is holding the address of another object. A possibilities, the variable possibilities is an array list of integers. Okay? So that array list, that variable possibilities is holding the address where that array list is stored. Now that array list also has indexes, and the very first index, the index of the first element, is 0. So if the size of the array list is 4, the first valid index is 0, and the last valid index is 3. The last valid index is 1 less than the size. So let's look at choosing a valid index for a moment, and here's one of the really common mistakes. If I have the variable math.random, math.random chooses a number, and this is a number line, between 0 and 1. However, it includes 0, it does not include 1. So you probably remember from math class when you draw this interval on a number line, you use a solid dot saying this math.random method might return 0. It might evaluate to the number 0. But it will never evaluate to 1. It might evaluate to something that is just a tiny, tiny, tiny bit less than 1, but it will never quite reach 1. And that's important. Now a cast. If I want to convert this number to an int, something without a decimal point, I can put round brackets in front of it and the letters int. That'll convert it to an int. However, there's precedence. Just like multiplication and division come before addition and subtraction, a cast has higher precedence than multiplication. So if I type a line of code out just like that, int I, int math.random times x, what I'm going to get every time is 0. Why? Because math.random will never be quite 1, and when you cast it to an int, it throws away everything past the decimal. So if you've got a number that's between 0 and 1, never quite 1, you convert it to a whole number, you throw away everything past the decimal, you've got 0. Okay, so this expression evaluates to 0, and the cast happens before the multiplication. So you end up with 0 times some other number, which is always 0, and you'll always get 0 in the variable I. So what do we want to do? We want to evaluate that we want to multiply by some number before we do the cast. So math.random times x gives us some number between 0 and x, never quite x. If you cast it then to an int, you'll get an int that is between 0 and x minus 1, including x minus 1. You might get x minus 1, but you'll never quite get x. And so we'll use parentheses around the math.random times x to force the multiplication to happen before the cast. And the biggest number we'll get from this is 1 less than x. Now notice, we might get 0, we might get 1 less than x, but we'll never get x. If we're trying to choose a valid index, we want something that might be 0. It might be 1 less than the size, but it'll never be quite the size, because if we end up with 4 and the size is 4, we'll get an array index out of bounds error. And so hopefully that's enough to help you choose a valid index. Now let's look a little bit about this whole random guess method and what we're trying to accomplish there. The random guess method of a square. So if you have the address of a square object and you call its random guess method, when you call a method, memory is set aside for that method and its variables, and random guess is going to have a variable temp, and that memory does not live on the heap, it lives on the stack. So that variable temp is going to be on this stack. But there is a connection between that method and the object that it was called from. So if I have a particular square and I call its random guess method, there's a connection between that method and its object. And so if within that method I use the variable possibilities, I'm going to be accessing the possibilities variable of that particular object. And so if I say possibilities.get with some index, say I use possibilities.get1, I'll end up with a 5. And if I store that in the variable temp, I end up with, okay, so we're storing integers here. Integers are objects. Objects are held by reference. I end up with a connection between temp I need to zoom out a bit. Okay, so if I say possibilities.get and I assign possibilities.get1 and I assign that to temp, I end up with a connection between temp and the item at index 1. In this case, it would happen to be a 5. So then when I say possibilities equals a new array list of integer, what that does is it creates a new object on the heap, which is an array list of integers that doesn't have anything in it yet. And when I assign that to possibilities, it breaks the connection between this array list that possibilities was already pointing at, and it makes a connection between the new and empty list. And then when I say possibilities.addTemp, it puts that 5 inside of the new array list. Now, I'm being a little bit careless here in my diagram because the array list does not hold basic data types. That 5 isn't stored directly inside of the array list. It's actually a separate object, and the array list is just holding addresses. But for our purposes, we can treat it as if the 5 is directly inside of the array list. And hopefully that clarifies the picture. All of this, when there's no longer any references, once that method finishes, it's erased from the stack. And so now there's no longer anything holding the address of this array list in memory that held all those items. Java keeps track of its objects and how many variables are holding its address. And if you ever get to a point in the program where there are no variables pointing to a particular object, then Java erases that object from memory, frees up that memory, and makes it available for other things. And so, so random guess is going to grab one random item out of the array, create a new empty array, store that new empty array in possibilities, and then store that one object that you selected out of the old array list inside of the new empty array list. So you end up with just one item in the array list. I hope that helps. I hope that clarifies some things. I just want to show you just a little bit of code to kind of help. So with this whole random guess thing, what I've got here is this is just a simple little program, and I want to encourage you when you're confused about exactly how something works. It is sometimes a good idea to just create a simple sandbox project with nothing more than just a main method, and then just to write 3 or 4 lines of code and run them and test them and print out what happens. That way you come to a complete understanding of exactly what that little line of code does before you include it or put it into a much larger project. It sometimes helps. It's not the solution to everything, but when you're trying to figure out how a particular method works that is something that is a part of the Java standard library, it's often useful. So that's what I've done here. I've created a simple little array, some array, and I've filled it up with the numbers 1 through 7. I've gone through a loop, picking random indexes, and then printing out both the index and the value that's in the array at that index. And I've done the same thing for an array list. Now I've got 2 loops here, one to fill up the array list, and the other one to print out the stuff at the indexes. So, and I've got some comments up here. So the comments. First important fact, math.random provides a non-negative number less than 1. So when I say non-negative, I'm not trying to be tricky with words here. I'm just trying to be very explicit. What do I mean by non-negative? Well, that doesn't mean that it's positive. Positive would imply that it's greater than 0. Non-negative implies that it's not less than 0, meaning that 0 is a possibility. Math.random might return 0. Less than 1 means that it will never be quite 1. It might be something that is slightly less than 1. So I'm being very specific and very careful with how I choose my words here. Non-negative number less than 1. And it is very important. Second important fact, casting it to an int before multiplying will always result in 0. Next important fact, using parentheses can force the multiplication to happen first. Next important fact, if you multiply by x, then cast to an int, your minimum will be 0, but you'll never get x. Last important fact, 0 is the first valid index of an array or an array list. And the last valid index is 1 less than its size. Now what if its size is 0? If the size is 0, then you don't have any valid indexes. So what does this do as it's written? Well, I don't have any parentheses. There are 7 items in the list. Okay? I don't have any valid, there are 7 items in the list. The first valid index is 0. The last valid index is 6. If I do not use parentheses, the cast happens first, So math.random cast to an int will evaluate to 0. 0 times 7 is 0. So I will store a 0 in index, and then I will print out the thing at index 0. And similarly for an array list, I'm doing exactly the same thing, except I'm saying ArrayList.size. Well, I've added 7 things to the array list, so its size is 7. But without the parentheses, I get a 0 times 7, which is always 0. So if I run my little program, sum array sub 0 is equal to 1, and I get an index of 0 every time. So now if I put parentheses around my statement to force the multiplication to happen before the cast, you'll see that it picks random indices that are between 0 and 6, including both 0 and 6, but never quite 7. And that's good because I don't ever want I don't ever want an index of 7. So my indexes here were 2, 4, 5, 0, 4, 4, 1, 3, 1, 3, and here and if I have the thing at index 2, that's a 3. The thing at index 4, that's a 5. Even though my first number is 1 and my second number is 2, well, the first index is 0 and the number there is 1, so it's an off by 1 every time. Same thing with the array list. I hope this video helps. I hope it clarifies some details. If you still have any questions or problems, please send me a message in Canvas. Thank you. Bye.